This red line was before the TCHQV, so it was smaller than TCHQV. Okay. Anyway, so in real flip-flops, modern flip-flops, so in the old days when we made flip-flops, they looked like this. We had a positive hold time, and it was after the clock edge. Modern flip-flops look like this. This right side of the edge is before the clock, which is kind of weird. We'll explain later on why this comes about when we start talking about what's inside flip-flops, but that's a discussion for later. So in this case, if I were to draw the hold time is from here to here. That's T hold. And T hold in this case would be equal to, say, -3 picoseconds. And T setup, T setup is always positive. In this case, and it has to be bigger. The absolute value of it is bigger than its value is always positive. It's bigger than the absolute value of T hold. So something like 5 pico or something, right? This is T setup. So there's some kind of weird things happening with this. So what this says, this is a restricted region. So I don't want, let's make it, it's another color I can pick. I don't know. Green's not a good one. Oh, well, whatever. I don't want any change right here in D input, but I could have a change here. So for instance, if I were to take this little black line here, I could have this situation. D changed there. D actually changed before the clock edge and went low. This is okay. You see D is not changing in this little green area. It stayed stable. It went after, but it actually changed before the clock edge. It just so happened that's the way they work. T hold goes to end of restricted region when TCHQ goes to Q change. Julian, I can't understand this. It's by design. T hold and TCHQV are unrelated. They're just independent values. T setup
this would be considered non-ideal behavior, right? Because it's happening before the clock actually pulses.
No, this is the behavior of the circuit, real behavior of modern flip-flops. This is the way they work.
All right.
And it's fine. This is by design. I wouldn't say it's by design. It just happens the way we build them. This is the way they work.
The negative sign for the T-hold is because it's outside the restrictive region?
No, it's because it's happening before the clock edge. The old flip-flops, it always used to happen after the clock edge, and that was by like electrons, a current flows in the opposite direction of electrons because they didn't know which way. When they defined current, they didn't know the electrons existed. Well, it's the same idea here. We defined flip-flops in the old days as having a hold time after the clock edge. Then as we kept improving the flip-flops and made them better, this thing kept moving smaller and smaller and smaller, and eventually it became negative. They still work fine. That's why I said this is the hard part. This kind of warps people's brains. I don't know, but this is the way it really works.
So would the value of Q be high or low then?
For this circuit here, if I were to draw Q would look like this. It would go, look at this clock edge. At this clock edge, it samples in this region right here. And so the output would still go high. That would look just perfectly fine. The output would go high.
So what does T hold represent in this case then? Does it even matter?
T hold is the right edge of the restricted region. It's the time from the clock to the right edge of the restricted region.
Just the difference between the clock and when you need to sample. Okay, gotcha.
Yep.
Okay, so can I ask the question of how does this make any sense? In the sense that
That's what I said, this was going to warp your brain, but how does it make any sense?
Yeah, how does it sample a quantity that effectively happens before it's told to sample? If that makes sense.
Well, I will explain that in detail to you, but
Okay.
It will take me, we'll have to learn about how we build flip-flops and so on. At this point, you got to trust me. That's the way they work.
Okay. That I can
Otherwise,
do.
I'd have to spend probably about 40 minutes or half an hour explaining this in detail. It's just the way they work. It's just, it relates to the delays, because what happens inside the flip-flop, the delay from the D and the clock into the real circuitry is different. And because of that delay, the data can change. The data can change before the clock edge, but it's delaying before the actual sampling takes place. So you're thinking, oh, ideally it's sampling right at this time, but that's not really what happens. The sampling happens a little earlier relative to the D.
Mm-hmm. Oh yeah, I
Okay.
guess yeah. So the sampling happens like at that exact same moment, but because the D is delayed, it's sort of shifted to the right.
Exactly.
whole.
Exactly. Maybe that explains it.
So just to make sure I'm understanding correctly, any change that happens to the D signal in the time like between the T hold, I guess, it doesn't actually matter for the Q value.
Well, the way I like to explain it, we have this restricted region. We don't want any changes in the restricted. So as long as D is not changing in the restricted region, we're good. If D changes in there, we don't know what's going to happen to the output.
Okay.
That's the good way to think about it, I think. Anyway, this is a weird concept, but we'll be visiting it a lot over this course.
So, Professor,
Yep.
do we determine the restricted region or to be predetermined for us?
The restricted region is just something you're given. It's a, when you make a circuit and you're given this flip-flop, you'll be given these parameters, right? You'll be given 3 parameters for your flip-flop. So I'll have T setup, T hold, and didn't that work? And you'll be given TCHQE. Maybe this
Okay.
is 10 people. And these numbers, you don't change them. You're just given them for your circuits. Then you have to make sure you design your circuits around these characteristics.
Okay, thank you.
Professor, please could you
Yep.
explain how you get the Q?
Sorry, what's that?
Could you please explain how you get the Q form?
How did I get the Q here?
Yeah.
So what happens is the clock, this is a positive edge trigger flip-flop. So on the positive edge of the clock, it's sampling the D input, right? That's the way a flip-flop works. So I said, I drew the circle. I said, positive edge. So let's draw it in red now. Let's draw it in purple. Purple. So I sampled right here, right? That's when we're sampling it. And what it's sampling is the D input. And what it samples is it's sampling within this restricted region. Okay, that's what it's actually sampling. And here it was always high, so it sampled to high. So the output will go high, but there'll be some delay, right? And that delay is this delay here. That's the TCHQV. Okay?
Thank you.
Well, wasn't that fun? So now we have some time for some bonus questions about this weird and wacky operation.